So today's lesson, we're talking about the compression clamps. When you make the compression, we use a nylon. So no nylon compression clamps are this is for the cables are connection. They are black on the gray color and the metal crows are plated are brass. They are the kind of the connections are compression clamp. In the meantime, are IP. IP is an internal protection rating for the cable. So we have to follow the AS60529 standard. The function is to protect against the hazardous part, wire, solid, and objects. So the IB0 is a no protection, IB1 is a full penetration of the 50 millimeter, and the IB2 is a full penetration 12 by 5 nanometer, and IB3 is a access probes 2 by 5 nanometer. Xenobis are penetrated. IB4 is a 1 millimeter. IB5 limited ingredient or dust. And IB6 is a total projection angles. These are kind of the IB projection. We also need to do the safety testing. We have to do the safety testing. We have to measure the other system, insulation of the system, polarity test, no transposition, no short circuit, no interconnection with the another circuit, and lose our impedance, RCD, and the control operation. ASR 3000, clause 8 by 3 by 5 and the 8 by 3 by test need to be followed. Regarding the installation, ASR 3000, clause 3 by 9 by 3 by 3, 3 by 9 by 4, 3 by 9 by 6, 3 by 9 by 3 by 3 by 2 by 8, 1 by 4 by 40, 6 by 1 by 2, 6 by 3 by 2 by 1, 6 by 7, and the appendix G need to be followed. So those are the connection and the safety protection. So the question one, where the circuits are wired TBS cable and face to metal cable tray, must be the cable tray need to be added. So in this case, we have to follow the clause of 5 by 4 by 1 by 2, coded is a building material, coded building material share we add a cross with the clause of 5 by 4 by 6. We are the 5 by 4 by 1 by 2 is how to utilize the cable tray, how to do the protection. Question 2 is which coded wire into circuit breaker. In this case, we have to use an active wire crossing the cross at 2 by 5 by 1. And also the question 3, what is the minimum insulation resistance acceptable for the light bulb of the cable to us? In this case, are the mega ohm. This is the 1 mega ohm crossing the cross 8 by 3 by 6 by 3. It must be the 1 mega ohm. Is the orange circular TBS cable used exercise regarded as an armor cable? Answer yes. This is a circular orange circular cable, and this is for the radiance of 5 to the 1 volt, and this is the application. We use for the main subway, sub-circuit angles, control body, dry or the underground gas. In this is insulation of BBC 90. We had to follow the ASNS 5000.1, taking 100 meter and 500 meter. So this is the kind of the orange circular. To measure the insulation resistance of the circuit, what DC voltage setting on the mega should be used? The answer is the 8 by 3 by 6 by 2. We had to use the 500 volt. What color of the combination of color must be used to identify the arcing conductor? So answer is the green yellow. So reference is the table 3 by 4 of the AS3000. You can see the color for the installation wiring. And also the black cable be used for the straight wire or the fixed wiring lighting circuit. Answer is no, because of the across the cross at 3 by 8 identification 3 by 8 by 1. We have to follow the standard. The question 10 is electrical connection between the conductor and the equipment share we provided with the continuity. So this is for the we have to write in the appropriate rated mechanical. So 4 by 3 by 3, 4 by 3 by 3 by 1 need to be followed. So this is the connection of the two light controlling, and also the installation we have to follow the dose standard. This is a wiring diagram, circuit wiring diagram. So this is for the tools are switch are controlling the light. This is the connection diagram, and this is for the circuit connection diagram. And here is a real wiring diagram in this one. AC supply left panel, fuse, and a switch panel. So this is for the circuit diagram. Circuit diagram, here is the real connection diagram. And also the way to see that our THS wiring. So this is the wiring diagram. So in this case, these are the circuit diagram, and this is for the wiring diagram. So those are the circuit diagram, and this is the wiring diagram. So this, if you see that this circuit diagram, this is a wiring diagram like this. This is a circuit diagram, wiring diagram. This one, circuit diagram, and a wiring diagram. Here is a symbol of the symbol. So this is for the switch, fuse, circuit breaker, RCD, wrong socket outlet, the symbol. And the best type of the electrical diagram to use in the output boarding, there will be the inside the circuit diagram. And the circuit diagram is a delay diagram either to be described in the connection of the every component or the circuit, and can also be used to assist with the operation circuit diagram. Operation circuit diagrams are sometimes referred to as a schematic diagram. So this is the contactor crossing, not joy. This is the contactor joy. This is the contactor joy. Contactors are. Here is a circuit diagram conversion. So this is called as a data diagram, and here we use the operation principle. So this is the operation controls tutorial. Here is the switchboard mounting. Switchboard mounting. So this is the open switchboard mounting. We connected, and this is switchboard mounting open and close. This switchboard can be used by this diagram. So this is a normally open and normally closed. And this is a normally closed. This is the way you have to open. So this is a main circuit breaker can be referred by those diagram. However, is that we have to use the internet speed. Use the internet search. Provide a symbol for the following: manually operate the switch, normally open, manually operate the switch, normally close, fuse, lamp, illumination, lamp signal illuminating, signal pole, double throw switch, SPDD tie delay contact, circuit breaker signal pole, double pole switch, triple pole switch, and slider switch. Push button switch, and a push button emergency stop. The type of the wirings are enclosure. Protection is provided by the conduit for the mechanical protection and also the moisture and the heat protection. Type of the conduits are the rigid PVC conduit and also the heat HFD conduit or the flexible non-metallic PVC conduit, corrugated PVC conduit, non-metallic trunking, and also the compliant marking. So here will be the this is for the specification. The first one is the UPVC. This is the material type. Electrical means either use RS2 8 S3. This is compliant standard. 20 millimeter is a nominal size, and H is the duty size classification. This is the kind of the conduit specification. The color can be the medium duty is a gray, heavy duty orange. Installation method is that we have to cut the conduit. Tools are latched by using a hacksaw and a conduit cutter and support the edge by the use but try to avoid the cables are damaged, and we have to use a setter and also the bending system. So bending is when you bend it, there will be the radii 6 style of conduit diameter. And compliance standard, we have to follow the AS/NS 2053 or the AS/NS 1061-386. We use a C conduit, flexible metal conduit, rigid and flexible insulation conduit, and the corrugated insulating conduit are utilized. So this is the conduit and the gear conduit. So the AS 308, the standard to determine the current carrying capacity and derating. AS 3000, appendix C is a table C9, C10, and the HIB conduit, where you use the elbow T to change the direction. Corrugated conduit and medium duty, gray, heavy duty, orange. Flexible conduit, we use the vibration and machine. This is for we use for the loading. So we had to prohibit the uses. PVC conduit must not be used for the high temperature, must not be used for the halogens or flames are retardant. Segregations are every low voltage high voltage connection. We had to use a segregation between a low voltage high voltage cable. Installation of cable. We had to provide a mechanical support for the conduit tracking and tray support. Hazardous area, we had to use a hazardous area protection system. Wire protection, cable size AS3008 have to be utilized. This is the current carry capacity and the installation method. So cable 3 this is for the 3x1 is enclosed in air, 3x2 enclosed in air, 3x3 body direct underground, and 3x4 is underground wiring enclosure. We have to use an appropriate table to choose. Use a table to choose a type of cable, single go, and the cable side, and the conduit side, and the trunking side need to be selected. So this is for the cable and there's a conduit where a cable passing through the wall and flow. In this case, this is passing through the wall, this is passing through the flow. So if you want to pass through the cable wall and the through flow, we have to follow the AS3000 standard. So the claw is a 3x9x9x3. Appropriate fire barrier need to be provided. The overhead shelves are close fitting to wiring system. At least 50 millimeter from the any service opening. So in this case, this is the website, view.electricaltrade2018.blogspot.com, and we're going to see that the G106 textbook, section 5, page 9 of the 18 is a table, and there's 10 of the 16, 18 the testing. And the next one, the insulations are separate. Ground insulation for the fire class and the cellulose. High sunlight protection, where to fall, utilize the standards of AS3000, clause of 3x10x3x7. Conduit suitable for the using for the sun are the marked with the T, so that it follow the AS-NSS 2053x1, AS-NSS 61386.1, AS-NSS 4296. So this is for the typical case of RCD and the switchboard applications, RCD and supply, and also they will be the active wire, neutral wire, and the ground wires are connection. So this is the reverse connection diagram. Here is a circuit diagram. So this circuit diagram, this is a reverse connection diagram. So this is for the wirings we wire up on the cable tray. If you want the cable tray, this is cable tray wire. So we wire run on the cable tray like this way. So this is the conduit, and this is for heavy duty on the cable tray. We run the wire like this. Here is the trunking. On the trunk, wire we connection, we join the connection to the switch, also the sub bulbs, branch, and also this is switch. This is lighting. So this is for the give a trunking and the conduit, and the conduit coupler and connected to the light and the switch connection. So this circuit diagram is here. This one is this real connection diagram, and this is for the circuit diagram. All this. So today's trade 2, what I teach you is a cable protection system and a circuit wiring diagram. Now E107, G106. So this is the E107, G106 how we finish. Then we also talking about the G106 answer for the electrical trade 2. So this is for the we have to follow the this selection installation of electrical equipment for the swimming pool. So swimming pool system. This is the kind of the swimming pool zone 1, zone 2, zone 3, and kind of the electrical equipment utilization. So this is swimming pools are closed. So that we have to use this table. Protection against the indirect contact is provided by the automatic disconnection of supply. So the machine disconnection type for the power circuit with radius less than 63 MBR. So this is the protections. So in this case, I would have to utilize this one, this clause, ASR 1 by 5 by 5 by 3. The protection by the automatic disconnection of supply. It is 0.4 seconds for the final circuit, 5 seconds for the other circuit. And dashboarding AC, the starting value of protected device must be disconnected the supply. What are the limit of dashboarding? So across through the 1 by 5 by 5 by 3, AC 50 volt AC or 120 volt DC. We were free DC. What are the four acceptable methods of protection against indirect contact specified in the AS 3000 and 2007? So this is the cross 1 by 5 by 5 by 2 is a method of protection. So the automatic disconnection of supply, prevent the fault current from passing through the body, or prevent the fault current passing through the body by electrical aspiration, limit the fault current. Protection against indirect contact by the automatic disconnection of supply is achieved by the two factors. What are these two factors? So this is the 1 by 5 by 5 by 3. So in this case, automatic disconnection of supply is intended to limit the prostatic dashboarding arising simultaneously accessible conductive path in the event of fault between the live path and the exposed conductive path of the protected adding conductor. Where may socket outlets be installed in the pool zone for the connection of pool equipment? So in this case, we have to follow the cross 6 by 2 by 4 by 2 socket outlet. In this case, zone 2 is a socket outlet installed in the pool. So share B is a automatic switching type incorporated in the Shiva supply units complying with the ASN 3194 zone 3 socket outlet. This is for the cross of BNC. You have to read the cross BNC. Luminance is the following requirement for the luminance. Zone 0 is this is about all the red color we write in. This is you read this ASN 6 by 2 by 4 by 4. In this case, you can read about this luminance. Zone 0 system, BLB cross 7 by 5. We follow this standard. And also the two alternative supply equipment for the circuit that supply the full filler pump is this is our 6 by 4 by 4 by 2 wiring system. This standard had to be utilized. And also the 6 by 3 by 4 by 5 luminance applies and other electrical equipment. We have to follow this standard. And also the cross 6 by 2 by 4 by 2 is a not mentioned about the socket outlet. So you have to read this clock how to install the socket outlet. In the meantime, this is for the location and the IP rating. So this location IP rating is you have to read the cross 6 by 3 by 4 by 1 is the protection equipment and appropriate IP rating system. So also you need to mention about the follow the table 6 by 2 selection and installation of electrical equipment for swimming pool, bathing pool, and a spa pool or the tub. So we have to refer the table 6 by 2. And also the table 6 by 2, also this also you see the figure 6 by 15 of the ASR 3000, 2016 addition. So you can see that this is the diagram of the zone. Why is the zone 0? Why is the zone 1, zone 2? You can read in this diagram. Similarly, in the meantime, you also follow the cross 6 by 4 by 4 selection and the installation of the electrical equipment. So cross 6 by 4 by 4 by 1 is a degree of protection required. And also the zone 0 kind of the IP protection, zone 1 kind of the IP protection, unified by 6 by 3. 6 by 2 by 4 by 2 is a socket outlet connection. Socket outlet connection, you have to follow the table 6 by 1. The 6 by 1 selection and installation of electrical equipment for the bath, shower, and other fixed water container. So table 6 by 1 is an appropriate equipment IP protection we have to utilize. Fixed water container, you have to follow the cross 6 by 2 by 2 by 2. This is a fish water container system you have to read through. And also that this fish water container and their diagram, why is a zone location. You can read in this diagram. So they also favor silver 18 or the zone dimension or the ground sparkle. You can also refer to this one. So the 6x2x2x2 is a sparkle or the task. The sparkle and task you have to read through this clock. How the sparkle and task. Water capacity and also the other system. So in this case, exported quadratic part is you have to refer the cross 1/4/62. The quadratic part of the electrical equipment. Also, instantaneous coordinates part, you also follow the 1/4/63. So, the instantaneous coordinate parts you have to refer the cross 1/4/63. And reasonable adding. Remember, adding in this case, you have to refer the adding times 1/4/3, accessible reliability. And also the adding accessible system is that you have to refer this one, adding time. And also the other saturation is you refer the cross 1/4/47. And also the 1/4/40 is the other saturation you have to refer it. So that this is the definition of the other saturation 1/4/48. And 3 example of the conductive flow. So this is the conductive flow 3 example. In this case also you refer this one. So this is the 3 conductive flow. Main adding conductor is the definition of main adding conductor is expressed in the 1/4/81. The conductor connecting the main adding terminal connection of the bar to the electrode or to the adding system or the source or the supply. So this is the main adding conductor. So identification is that you have to refer the 3/8/1. So installation of the adding conductor shall be clearly identified to indicate there is an identified function as active nuclear adding or the equal potential bonding conductor. So in this case, you have to refer the table 2/4 of the AS3000. So that we have to refer the protected conductor and also the insulation color you can see in the table 3/4. Color identification, you can see the 3/8/2. So main adding conductor is you refer the cross 5/3/3/2. So this is the main adding conductor definition. How to install the main adding conductor, you have to refer this clause. And also the table 5/1 is a minimum adding conductor size. So minimum adding conductor size you can read in the table 5/1 depending on the active wire size. So that this is the minimum adding conductor size you can select from this table. And 3/1/3 is a calculation method. Crossing area is a calculation. And also the sections are 5/5/1/4 is the resistance of the main adding conductor. You can read from here. The resistance of the main adding conductor is not more than 0.54. So in this case, you also have to follow the 5/8/2 minimum value of the resistance of final circuit. So this is the minimum value of the resistance of final circuit. You also refer this table. Main adding conductor connected to electrode program must be certified. These are the connected to electrode. They are the A, B, C, D, U, C. So accessible for the visual inspection. Be made by means of a suitable device provided protected against mechanical damage. The suitably protected against corrosion. So this is the all are expressed in the 5/5/1/2 connection to the main electrode. And also the hardware clauses are general, so the connection of electrical adding system to the general mass of the earth shall be achieved by means of the electrode. So in this case, you refer the 5/3/6/1. The connection of the electrical installation adding system to general mass of the earth shall be achieved by means of the electrode. So in this case, section 5 you have to refer. So the reference is cross 5/3/6/2. Accessible electrode site. You can see there's a material and there's a diameter on the side of the electrode. You can get it from the table 5/2. So the 3/6/3 is installation. So this is for the installation of electrode. So you can see on the Australia, New Zealand, the standard, the electrode site. location. The R electrode shall be installed in the location that satisfies the following condition. The R electrode maintain the aesthetic. So those R electrodes are location you can read in there. Plus 5x6x3, 5x3 by 6x4 location you can see it regarding the R electrode installation. So ambient link is you can see the 5x3x5 ambient connection. So this is the connection of the main switch board and the up connection at bar and the electrode connection. Ambient link cross-sectional area not less than the. So this is for the side of the ambient connection. Adding of enclosure containing consumer may not provide with a short circuit protection on the supply side made by the connection directly to the neutral bar in cross-section with the cross of 5x5x3x5. The insulation of the conductor may, in this case, made up to the supply terminal or service protected devices, short circuit protection provided by the service devices, electricity distributor, upstream service protected device may provide short circuit protection of the consumer may. And cross of 5x3x5x3 are mentioned about the identification. Where the ambient connection is insulated, the insulation shall be color. So this is for the you have to read this given 5x4, given 3x4, conductor colors for the installation wiring. So given 3x4 in the 3000, it mentioned about the conductor colors for installation wiring. So the no conductor color identification, you have to follow the cross of 3x8x2. So this is the color identification. So they also the ambient they insulated, the insulation shall be color green and yellow.
On the street.
And protected adding conductor is you can see in the cross of 1x4x100 to the protected adding conductor. So to protecting adding conductor diagram, you can see in the figure 5. Adding system pass. Adding system pass are you can see in the cross of 5x3x1. So they are the adding system pass you can see in the cross of 5x3x1. They are the protected adding conductor connecting the H4 connected pass, main adding conductor, main adding terminal connection bar, ambient connection between main adding terminal and electrode equal protection bonding. Protected adding conductor is explained about the arrangements. All the protected adding conductor shall be directly connected to the main adding conductor or the another point of the adding system. So this is the arrangement of the main adding conductor. Main adding terminal, any point adding. So and also that you can see about the two cross. Two cross are for the arrangement of the adding conductor and the adding pass. And the adding conductor material you can see that this cross 5x3x2. And to the adding conductor part, adding conductor. So adding conductor side, you can see there's a cross 5x3x3. This might be the adequate current capacity important aspect. Over current protection devices, you also follow the those standard. So those standards are when you read that through the 5x3x3.1x2, so they have to be utilized. Also that you have to read that table 5x1, minimum addings are copper adding conductor side, you can get from the table 5x1 or the AS3000. Conductor material, you refer the 5x3.2.1x1 conductor. Conductor adding conductor shall be or the high conductor copper and sharing in form on a stranded conductor or circular break conductor on a solid conductor having the cross-sectional area not less than 10 millimeter square, thickness are not less than 1.5 millimeter. So you have to refer to section 5, cross tie and a general. So the 5.3.2.2 is a conductor type. You can read from here, adding conductor, and also the bus bar. And 5.3.2.3 is a special condition you have to go follow. And also 5.3.2.2 is conductor type. So in this spring car pipe or the pipe converting gas, water, primary, liquid, other conducting material, electrical survey, enclosure, channel, US and others on median. And 5.3.2.3 for a special condition. So those are the you have to read as a conduct how the adding conduct side, how the adding conducting wall, how to provide the adding for the protection. You can read that those are pages. Also the 5.4 is mentioned about the adding equipment. So you have to read the 5.4 or the year 3000 regarding the adding equipment. And also the cross 5.3.2 is that you have to read the equipment protection bonding system. So this is the how the equipment bonding transformer export connected part, you can read it. So the 5.4.3 is a lighting point situation. And also the 5.4.6.2 connection to protected adding connector. 5.4.7 is a submersible pump. 5.3.2.3 is special condition. You can read it. And 5.4 is a continuity. So this is the adding connector share suitably with protected gas and mechanical and chemical deterioration and electrodynamic forces. So this is about a continuity system. And connection to the protected adding connector, you have to refer the cross 5.4.6.2. So this is a connection to the protected adding connector. Adding all the structural metal work, including connected building material, may be affected by the connection of the protected adding connector on the appropriate side. At one point of the metal work, provided that the resistance between the add bar and any part required to be added does not exceed the 0.5. And resistance or the function resistance or function at connector, you can read in the 1.2.2. And also that you can read all the RCD connection, cathodic protection. So those are appropriate connection diagram for the door equipment. So this is what you can see the supply, main switch, and the up bar, neutral bar, and also the adding neutral switch and also light connection. And also this diagram also shows you can see the service wire, outgoing final start circuit, service fuse, main other protected system. You can read in this diagram. And selection and installation you have to refer the cross fiber 1x2. The adding arrangement shall be selected and installed to perform the following functions. So enable the automatic disconnection of supply, enable the equipment requiring a reference function, designate the body different appearance or export connection, and provide effective reliable low impedance for paths, provide measure for the connection of exported connection paths. So those are the selection of the installation. And 5.2.1 is a protected adding system. You can read that as this passage, protected adding system. And adding of the equipment that you can also see the 5.4.1. So adding of the equipment to install, aspiration, and 5.7.4.3 is arrangement of the circuit. Export connected power electrical equipment supplied by a splitter circuit shall not be connected to the protected adding connector or the export connected bus on the source of the supply. And 5.4.1 is a export connected bus information. Electrical equipment. So comply ESN 31004 that's the installation. You can also read into this one. And 5.3.2.3 is a special condition. You also read it. So up to this stage, we're talking about the special condition and the conductive pattern, protected adding system. And 5.4.2, you can read about the socket outlet. So adding contact for every socket outlet shall be added. So there are exceptions are the exception 1 and 2. You can see that the same. And also the 5.4.3 is a lighting point saturation, lighting point connection, protected adding connector for the lighting point. 5.4.3, you can see the lighting point. A protected adding connector shall not be provided for the luminaire located in zone 0 swimming and the sparkle installed across and with the crosser 6.3.4.5 and zone 0 of the fountain or water feature installed in across and with the crosser 6.4.4.5. So this is the 4 type of lighting point shall not be added. This is lighting point, feston, lighting point where the luminaire added by attachment to the screw connected conduit. In this case, there's no thing you do to put, doesn't need, and also the ELB lighting point, we don't need as a protected sign lighting system. So up to this stage, we have already talking about the, especially there's a today lesson in trade 2 is we talk about the protected arting system, artist installation, how to select the wire, how to select the equal artist installation, how to select it, what are the conditions, what are the arting zones, those are expected for the trade 2. Then we also talking about the DC theory. So we're talking about the applied electricity circuit, series circuit. So at the end of this session, students should be able to define a series circuit and draw the appropriate circuit diagram, state the basic laws of the series circuits, simplify the series circuit, calculate the voltage, current, resistance, and power of series circuits, describe the effects of open and short circuits in the series circuits. So this is the connection of series circuit R1, R2, R3 that are connected in series. These elements are series. When the electrical current flows, only one current path. So the current I1, I2, I3 are the same. The same current flow through each element to the current ID. ID equal to I1 equal to I2 equal to I3. So this is ID current flowing. The absorbed charge of the body around the blue is equal to 0. This means that a body across the R1 is V1, body across the R2 is V2, body across the R3 is V3. So the V1 plus V2 plus V3 is equal to VT. So the absorbed sum of body around the loop is equal to 0. Because the V1 plus V2 plus V3 minus VT equal to 0. Kirchhoff voltage law. The applied voltage equal to the sum of the individual voltage. So the VT is the applied voltage, individual voltage are V1, V2, V3. So the addition of the all V1, V2, V3 is equal to supply voltage VT. VT equal to V1 plus V2 plus V3. So the VT equal to the V1 plus V2 plus V3. And the VT is a current is a 0.6 ampere flowing. So the resistance are the 5.6 ohm, 10 ohm, and 18 ohm. So the V1 is a 0.6 minus 5.6, 3.36 volt. V2 is a 0.6 minus 10 is a 6 volt. V2 is a 0.6 minus 18 is a 10.8 volt. So you add everything. V2 3.36 plus 6 plus 10.8, you got a 20.16 volt. So the VT is a 32, in this case are the 32 volt. So V1 16, V2s are 7 volt, V3 how much volt? So in this case, you can see the VT equal to 32 equal to 16 plus 7 plus V3. Therefore, the VT equal to 32 minus 16 plus 7, you got a 9 volt. So this is R1, R2, R3 are connected in series. So the B point and the C point are located. So from the A to B, voltage is a VAB. From the B to C, voltage is a VBC. Between C and D, voltage equal to VCD. And also the A to C, voltage equal to VAC. A to D, voltage equal to VAD. So this is how do we call it. So in this case, R total here, voltage total is given. So ID currents are flowing. So the voltage across R1 is V1, voltage across R2 is V2, and voltage across R3 is V3. So in this case, R equal to VT by IT. So the R equal to V1 plus V2 plus V3 divided by IT. So therefore, the R equal to V1 by I1 IT plus V2 by IT plus V3 by IT. This equal to R equal to R1 plus R2 plus R3. So this is for the how the Kacha polynomial. So the RD equal to the R1 plus R2 plus R3. So RD in this case are the R1 5 ohm, R2 6, 4 ohm, R3 11 ohm. So the RD equal to 5 plus 4 plus 11. So you got there 20 ohm. So RD equal to this R1 plus R2 plus R3. R1 is at 35 ohm. R3 is at 22 ohm. R3 is 75. So we have to find out the R2. So 75 equal to 35 plus R2 plus 22. Therefore, the R2 equal to 75 minus 35 plus 22. So you got the 18 ohm. C circuit often called the voltage divider circuit. Supply voltage VCC are connection. So R1, R2, R3 are connected in series. So the voltage cross R3 is a VR3. VR3 is a voltage cross R3 and it's a portion of the VCC. So the current flow is a IT. I equal to VD by RT. So VD divided by R1 plus R2 plus R3 I total. VR3 is equal to the ID multiplies R3. Therefore, you got is a VD multiplied R3 divided by R1 plus R2 plus R3. So therefore, the total voltage is at 10 volt. And they are 1 kilo ohm and 3 kilo ohm resistor. And series current total is ID. Method 1, ID here is divided. So in the total voltage 10 volt divided by the 1 plus 3 kilo is 4 kilo ohm. So the voltage 10 volt divided by 4 kilo ohm resistance, you got the 2 by 5 milliampere. So V2 is equal to 2 by 5 is the milliampere current and resistance 3 ohm, 3 kilo ohms. So you multiply, you got the 7 by 5 volt. Method 2 is we have to refer. V2 equal to total voltage 10 volt multiply with the 3 kilo ohm divided by the 1 plus 3 kilo ohm. So you got the 7 by 5 volt. In this case, are the total voltage VT, the total current ID, voltage cross resistor R1 is V1, resistor R2 V2, resistor R3 V3. So V total is providing. So in this case, PT equal to VT multiplied ID. So then PT equal to V1 plus V2 plus V3 is a voltage addition multiplied by ID. Therefore, the PD equal to V1 I1 plus V2 I2 plus V3 I3. Therefore, the power total equal to the P1 plus P2 plus P3. Because of the P1 equal to V1 I1, P2 is a V2 I2, P3 is a P3 I3. Also, the P total is IT square RT1 plus I1 square R1 plus I2 square R2 plus I3 square R3. So the power total is V1 square by R1 plus V2 square by R2 plus V3 square by R3. By this way, you got the PD. C circuit, IT equal to I1 equal to I2 equal to I3, VD equal to V1 plus V2 plus V3, RT equal to the R1 plus R2 plus R3, VD equal to P1 plus P2 plus P3. So those are the series circuits situation. So the voltage VT, this is the R1 150 ohm and then this is the R2 100 ohm. So the voltage across the R2 is 50 volts. So how you got is the ID equal to I2. So the I1 is equal to 50 by 100 is you got a half ampere. R equal to R1 plus R2. So the RD equal to 150 plus 100, you got a 250 ohm. V1 equal to I1 R1. So the V1 you half multiplied by 150, you got a 75 ohm. VD equal to ID multiplied by RD. So the VD equal to half into 250, you got the 125 ohm. VD equal to V1 plus V2. So the VD equal to 75 plus 50, 125 ohm. P1 equal V1 I1. So the 75 ohm half, you got the 37 by 5 watt. P2 equal to V2 I2, 50 multiplied half is 25 watt. P equal to VT ID. So the 125 multiplied half, you got a 62.5 watt. What happens to the current if the circuit is developed and the open circuit? When the open circuit ID equal to 0, what happens to the resistance of the circuit? In this case, RD equal to infinity ohm because the voltage called the VA cause open circuit is a VCC. So this is what happens to the circuit if the circuit developed is short circuit. So in this case, the R2 is short. So in this case, the ID will be higher, resistance will be lower. Voltage VA called the short circuit is, that will be 0. And then you have to do this practical exercise. This is for the E014 and also lesson 10. E104 lesson 10. We're talking about the applied electricity circuit, parallel circuit. So we have to revelation the CV circuit revelation. Lesson 10 is a parallel circuit. At the end of the discussion, students should be able to identify the terms of parallel circuit and draw the appropriate circuit diagram. State the basic law of the parallel circuit. Simplify the parallel circuit. Calculate the voltage, current, resistance, and power of parallel circuit. Describe the effect of open and short circuit current in the parallel circuit. So this is for the parallel circuit connection. Supply voltage VD, so R1, R2, R3 are connected in parallel. These elements are in the parallel circuit. So multiple current path. So in this case, you can see the current ID here. Path for the R1, R2, R3, multiple currents are flowing. Voltage called V1, voltage called V2, and the voltage called V3. The same voltage across each element. Therefore, that we can write down the equation. V equal to V1 equal to V2 equal to V3. So the current ID is flowing. So this is the idea is a less because of the current flow to I1, current flow to R2 is I2, current flow to R3 is I3. So that you add the all current plus ID minus I1 minus I2 minus I3 is equal to 0. The algebraic sum of the currents at the node is equal to 0. The total current ID here, I1, I2, I3 are flowing. We write down the Kirchhoff current law. The total current is equal to the sum of individual currents. This is Kirchhoff current law. ID equal to I1 plus I2 plus I3 equation. So this is a total current equation. And also the total current ID. The current I1 flow to R1, I2 flow to R2, I3 flow to R3. So R1 is 10 ohm, R2 20 ohm, and R3 25 ohm. Supply voltage 100 volt. So therefore, the VD equal to V1 equal to V2 equal to V3. This is equal to 100 volt. So I1 equal to the 100 divided by the 10, you got a 10 ampere. I2 equal to 100 voltage divided by 20 or 5 ampere. I3 equal to 100 volt divided by 25, 4 ampere. ID equal to I1 plus I2 plus I3, you got this 19 ampere. You got. R total is VD by ID. You can find out. Therefore, the R equal to VD by I1 plus I2 plus I3, you can get it. So this is the R total calculation. GD equal to V1 by I1 by V1 plus I2 by V2, VD plus I3 by V3. That is equal to the GD equal to G1 plus G2 plus G3, or the 1 by RT equal to 1 by R2, 1 plus 1 by R2 plus 1 by R3. So the 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the relationship. Therefore, we can find out the equations of 1 by RT, 1 by 120 plus 1 by 150 plus 1 by 100, 200. You got a 12 by 600. So this is 1 by 50. Therefore, the RT equal to 50 ohm. The circuit often are called a circuit current divider. IR3 is a current through the R3 is a portion of the I3. So therefore, the VD equal to ID multiplied by RT. IR3 is VD by R3. So IR3 equal to ID multiply RT by R3. You can get it. Similarly, to the powers of PT. The current flow to the I1, current flow to R2 I2, and current flow to R3 I3. So the in this case, PD equal to VD multiplied by ID. So the PD equal to VD multiplied I1 plus I2 plus I3. Therefore, the PD equal to V1 I1 plus V2 I2 plus V3 I3. You can get it. So therefore, the PD equal to V1 I1 plus V2 I2 plus V3 I3. PD equal to P1 plus P2 and P3. PD equal to ID square I1 square by the R1 plus I2 square by R2 plus I3 square by R3. So PD equal to P1 square by R1 plus V2 square by R2 plus V3 square by R3. So 20 volt is a supply voltage, ID flowing, and current flow to R1 is a I1, current flow to R2 is a I2. So I1 equal to 20 by 10 is a 2 ampere, I2 20 by 20, 1 ampere, ID equal to 2 plus 1 equal to 3 ampere. R equal to VD by I, so that 20 by 3 equal to 6.67 ohm. P equal to 20 multiplied 2 is a 40 watt equal, P2 equal to 20 multiplied 1 is 20 watt, P equal to 20 multiplied 3 is 60 watt, PD equal to power total equal to 20 plus 40 is 60 watt, you can get it. C circuit connection, ID equal to I1 equal to I2 equal to I3. VD equal to V1 plus V2 plus V3, R equal to R1 plus R2 plus R3. PT is P1 plus P2 plus P3. Whereas circuit connection, I equal to I1 plus I2 plus I3. VT equal to the V1 equal to V2 equal to V3, GD equal to G1 plus G2 plus G3, and PD equal to P1 plus P2 plus P3. Those are the formula relations between the voltage current and the resistance of the series and the parallel circuits. For the series circuit, the current are the same. So the supply voltage summation of all voltage, supply resistance is the summation of all resistance, supply power is summation of all power. This is a series circuit. Parallel circuit, supply current is equal to the branch addition of all branch current. Voltage are the same, and inverse of the resistance are total inverse of the total resistance equal to inverse of the all the resistance. Power total is equal to the summation of all power. So this is for the series and parallel circuit equation. So in this case, you can see that what happened to the voltage if the voltage cause a component open circuit. So this is the resistance R2 is open. In this case, for VDA unchanged, but the ID will be increased. RD will be increased and the ID will be down. So in this case, when there's R2 is open, voltage total is unchanged, the resistance will be higher and the current will be lower. What happened to voltage on the circuit is a short circuit. So that this ID is a short, it is VD equal to 0. The whole voltage will be 0. RD equal to 0, current will be increased. So there will be there's a short circuit. Then you do the practical exercise. And we see the lesson 11 of the DC circuit. So that in this case, we are talking about the series and the parallel circuit. Series and parallel circuit. Series and parallel circuit. When to revelation the parallel circuit connection, lesson 7 is series parallel circuit. At the end of this session, students should be able to define the series parallel circuit and draw the appropriate circuit diagram. Take the basic law of the series parallel circuit, simplify the series parallel circuit, calculate the voltage, current, resistance, and power of the series parallel circuit, describe the effect of the open and short circuit in the series parallel circuit. Series circuit is all the ID where you can see the equation for the series and parallel circuit. Series circuit, current, voltage, resistance, parallel circuit, current, voltage, resistance. In this case, G equal to 1 by R or the R equal to 1 by G. So you can see the R parallel circuits are below. They are the kind of the parallel circuit. Which R1, R2 is series circuit, R3, R4, R5 is a parallel circuit. R1, R2, R3, R6 is a series and also combination of the R3, R4, and R5. Here is a R1, R2 is parallel, R2, R4 is parallel. And this is a straight connection. This is a series connection straight, this is a parallel connection straight. So those are series parallel. This is a parallel element and the multiple current path. This is R2, R3, R4, R5 are the this is for the multiple current path. So this is parallel connection. So this R2, R3, R4, R3, R2, R4 is a parallel connection. So this is the parallel circuit here. The current will be flowing to this one, And also this way that we can combine by the RP. R3, R4, R5. By combination, you can call it RP. So the multiple current part is a R3, R4, R5 is a this is for the parallel is equal to RP. Single current part is a R1, R2, R3. R1, R2, RP, and R6 combination equal to RP. And also this is for the equation is that this connection here. So that connection given. So that in this case, RA squared to the R2 plus R3, you got the 100 plus 80, 200 volt, and RY. So this is firstly you got to add. RA to 120 plus 80, you got the 200 ohm. RY is the RH and the R4 parallel. So the 200 and 200 parallel, you got 100 ohm. So this is for this one. You can got the 100 ohm. So this 100 ohm plus 50 ohm and 60 ohm, you got the 50 plus 100 plus 60, you got the 210 ohm. So this is for the connection diagram of this connection here. So this will be the RA equal to R1 plus R2. Firstly, the R1 plus R2, you add RA. So this will be the R1 plus R2. And RB equal to this 30 ohm and the 30 ohm parallel, you got a 15 ohm. And also this one, also the parallel, RC equal to R2 plus R5, so that will be the 20 ohm. So the RD equal to RC and the R6 parallel, you got the 10 ohm. So that will be the, and the R total equal to this one and this one, plus this one, R7, R8. So you got 15 plus 10 plus R7 plus R8, you got this at 100 ohm. So this is the way we calculate the total current, total resistance. So this one you also have to make the connection. So the R2 and the R5 is a R2 and R4s are combination series, and R3, R5 are series. So the R3, R5 and the R2 plus R3 plus R5 and R2 plus R4, they are connected in parallel. So the RB equal to you can partially you can right. R2 plus R4 is a 18 plus 10. So you got the, and also R3 plus R5 56 by 27. So RB is this way the 28 and the 83 are parallel. So you got the 20 plus a 9 volt. So this is what the 21 9 volt here. This one and R1 here, R2 here, R1 this one, R2 here. So the RB is at 20 by 9 volt. So you got the condition. So the 33 plus 20 plus 9 volt plus 12, you got a 65 by 9 volt. Then you have to calculate the I total current. So this is for the total voltage 20 volt and resistance at 35 by 9 volt. So you 20 volt divided by the 65 by 9 volt, you got a 303 milliampere. V35 is this voltage here. So that this 303 milliampere minus 20 plus 9 volts, you got a 6.35 volt. So I24 you also have to calculate. So that will be the 6.35 volt divided by the 28. So you got the 22 to 6.60. 6 milliampere, you got it. Therefore, then you also see that this connection R3 is a 60 ohm, R4 40 ohm, R1, R2 20, and a 16 ohm. So you add, so the RB is a R3 plus R4. So that will be the 60 multiplied 60 plus 40, you got the 24 ohm RB. So that this RB 24 ohm and so 16 ohm and 20 ohm you add, the total resistance will be the 60 ohm. And total current ID can be calculated. So the 30 divided by the 60 ohm resistance, you got a half ampere. And voltage across V1 can also be calculated. Voltage across V1 is a current half and a resistance 20, you got a 10 volt. Voltage across V2 is a current half, resistance 16, you got a 8 volt. And voltage across VB is a current half and resistance 20 volt, you got a 12 volt. And for power total can also be calculated. In this case, the current is a half ampere and voltage is a so power to the voltage P1. So then the voltage is a 10 volt and the current half, you got a 5 watt. P2 is a current is a half and resistance is a 8, you got a 4 watt. P3 is a in this case you got the resistance square, voltage square divided by resistance. Voltage is 12 square by resistance, so there's a 2 by 4 watt. P4 is 12 square divided by 40, 3 by 6 watt. And also the total voltage power can be calculated. So that will be the resistance voltage 12 volt and the current half you got the 6 watt you got. B total is a voltage square 30 square divided by the total resistance 60, you got the 15 watt you can get it. Therefore, the PD equal to the 5 watt and 4 watt and 2 watt, 4 watt, 3 watt. Say you got a 15 watt, you can get it. Therefore, also the supply voltage 30 volt, resistance R2 16, R4 R20, R3 is R5 20. So therefore, you can calculate is R4 and R5 parallel, you get this 20 and 20 parallel, you got 10 ohm, and R3, and so this 10 ohm multiplied R3, you got this 16 ohm. So this 16 ohm is a parallel with the another 16 ohm. So this one parallel, you got 8 ohm. Then this 8 total 8 ohm plus with the 2 ohm. So then we need total resistance is a 10 ohm you get. Therefore, the total current ID can be calculated. Supply voltage is 30 volt. Total resistance is 10 ohm, you got a 3 ampere. And V1 can be calculated. V1 is a, this is for the resistance is a 2 ohm, current 3 ampere, you got a 6 volt. And then V2 also we calculate. V2 equal to V5B equal to VT minus V1. So VT is a 30 volt minus V1 is 6 volt, you got a 24 volt you got. So this voltage is a 24. V3 equal to that, you can also see there's a 1/2 ampere. So this current here 1/2 ampere because the current 1/2 will flow. The 1/2 ampere by 6 volt, you got a 9 volt. So the V4 equal to V5 equal to VSB minus V3, 24 minus 9, you got this 15 volt you got. I4 equal to I5. This is the voltage is at 20 volt and the by resistance are 20 ohm, you got a 3/4 ampere. So this is the way that you can see the current and the voltage flow in this circuit. And power total can be calculated. The voltage is 6 volt. P1 voltage power can calculate the voltage 6 volt and current 3 ampere. So you got the 18 watt. P2 can also calculate the voltage 24 volt and current 1/2. So therefore, you got this power 36 watt. P3 can also be calculated. In this case, our voltage equal to the 9 volt and current 1/2, you got the 13.2 watt. P5 also we need to be calculated. In this case, our voltage is a 15 volt and resistance is a current is a 3/4, you got the 11.25 watt. Then you can calculate the power total. So that way you have to add all the power across P1, P2, P3, P4, P5. Then you can get this 90 watt, you can get it. So this is also that we also need to calculate the voltage P4. So in this case, the supply voltage is 600, and also that you see that the voltage across this one is the resistance is 1000 multiplied, and the two resistance combination addition, you got a 4 volt you got. And also the VB also calculated. The supply voltage is 6 volt divided by the 500 divided by 500 plus 1000, you got a 2 volt you got. And VAB also need to be calculated. Again, that will be the VA minus VB. So VA and minus VB you get. So the 4 minus 2, you got the 2 volt you got it. Then you have to do the practical exercise. So series per circuit. And regarding this advanced diploma, you have to accept the site. Enter to IUN.college.com. And we also see the weekly lesson. Then we consider associate degree applied engineering, and on this side. So this side is a college.com BAppEngLesson electrical electronic resources 1.83. So you create this one, then you go down you find as a advanced diploma. So electrical IQI Technical College Campus electrical diploma 2022.htm. So you click this side, you can see the electrical diploma. Advanced diploma electrical engineering. So in this case, though then you have to view the YouTube video. YouTube video for electrical engineering lesson. You click it, then you click the lesson. By clicking the lesson, you can also see the lesson. So last week we have already talked about the E0s are 82. E082 is we talk about the engineering physics. So this week we finished this one. So we have to read this E1 to say engineering mathematics. E1 to say engineering mathematics are all the slide lesson you can see there here. highlightcomputer.com/video lesson.pdf. By clicking the this side and you read the page 87 to 101. This is for the written notes for the video lesson. Those video lessons are you can read here. Lesson 1, 2, 3, 4, 5, 6. And also the lesson 7. So those are the video lessons. You have to read those video lessons. So the topics of the video lesson that you can see here. So this is the way you can read the advanced diploma electrical engineering. Firstly, what you have to do is you have to enter the name IQI Technical College.com/electrical diploma 2022.htm. www.iqi Technical College.com/electrical diploma 2022.htm. Then you click in this side, you got the electrical diploma. You go down and then you see that video lesson. So you can see here the YouTube video for electrical engineering lesson. You click it. After you click the lesson. So you click the lesson, you can see that E1 to say that engineering mathematics. So you go down here. And then you see the E1 to say that engineering mathematics. E1 to say engineering mathematics. So there's the video, the link here. highlightcomputer.com/video lesson.pdf. By clicking this one and read the page 87 to 101. This is for the written notes for the video. Those videos are here given. Lesson 1 to that. Lesson 6. Those videos you read. And here is the topic of the video lesson. This is the way you can study the electrical diploma.